Hey everyone, welcome back to the channel. In today's video, we will be diving into one of the most crucial steps in any data science project, exploratory data analysis or EDA for short. This is where we explore the data, understand its structure, uncover patterns, and draw insights all before jumping into modeling. So, what exactly is EDA? Simply put, it's the process of analyzing data sets to summarize their main characteristics, often with visual methods. It helps us clean data, handle missing values, detect outliers, and discover trends. Think of it as getting to know your data before you let the algorithms take over. Before we dive into the code, let's understand why exploratory data analysis or EDA is so important. EDA is crucial because in the real world, raw data is often messy. It may contain missing values, inconsistencies, outliers, or even irrelevant information. Jumping straight into building a machine learning model without exploring the data can lead to incorrect insights or a poorly performing model. By performing EDA, you gain a deep understanding of your data and can make informed decisions about feature selection, data cleaning, and transformation. In short, EDA helps you ask the right questions and get meaningful answers before any modeling begins. Now, understand the key benefits of EDA. Understand data distribution, detect missing values and handle them, identify outliers and anomalies, visualize relationship between features, discover trends, patterns, or insights. EDA is essentially a detective process. It helps you uncover the hidden stories behind the data and ensures you are ready to build effective models later. Now that we know why EDA is essential, let's get started with Python. To get started, we will be using some popular Python libraries like Pandas for handling data, Matplotlib and Seaborn for visualization, and NumPy for numerical operations. Let's jump into the code. So here I have chosen red wine quality dataset for today's EDA. This dataset is great for exploring relationship between different chemical properties like acidity, sugar level, alcohol content, and quality of wine rated on 0 to 10 scale. Here we are only focusing on EDA, not going to do any kind of predictions. So let's get started. So let's start with loading pandas. Next, we are going to load our data set. We are going to load first 5 rows of our data set using df.head. Let's run this. As you can see, we have different numerical features such as fixed acidity, volatile acidity, and pH, alcohol, and also have main importantly our target variable, which is quality rating. Now let's see summary of our data set using df.m. It tells about data type of different column such as fixed acidity has floating data type and our quality has integer data type. It can also tell us if our column has any null values or not. Here you can see we don't have any null value. You can also see null value using df.isNull dot sum. Here you can see we don't have any null values in our data set. If we have null values, we can impute it using different imputation methods such as mean and median. Now let's see the descriptive summary of our data set. So it gives insight into distribution of our numerical features such as count, mean, standard deviation, minimum value, maximum value. Okay. If you want to see the shape, we can use df.shape. It tells us how many number of records we have and how many columns we have. Now, if you want to see the columns. We can use df.columns, list down all columns name. You can see. Now we can see df.quality.unique. We can see the unique values in our target variable. You can see we have 5, 6, 7, 4, 8, 3 as our quality rating. You can see more high quality, the more good the mine is. Okay. Now we can see if we have any duplicated value in our data set using df.duplicated. It doesn't really help in prediction, but it might affect our prediction. So if we have, we can remove it directly. You can see 240 rows we have as duplicated. So we can directly remove this using df.drop. Duplicates in place is equals to true. It means we are permanently removing the data set that is duplicated. Now you can see df.shape. 1359. Earlier it was 1599. Okay. Now let's see the correlation, which is a basic relationship between all features using df.core. It helps us identify which feature is strongly related to wine quality. We can also see in proper visualized way using our heat map. So let's do this. First import Matplotlib. And then Seaborn. Giving figure size using fixed size. Let's run this. You can see it's the visualized way of seeing correlation between our different features. It tells us about positive and negative correlation between our feature values in the data set. Now let's visualize using different plots. Let's see the value count of our quality, which is our target variable. You can see like quality 5 and 6 have so much count as compared to other quality. It tells us about imbalanced data set. Now let's also plot this. So it's our bar plot between wine quality and the count. Let's see distribution for each of our columns in dataset. So okay, you can see every plot is joined. So this is kind of overlapping. You can see individual plots also. Just change the name of your features. Here I am plotting of alcohol. You can see alcohol versus count. Okay, let's plot pair plot. We are using pair plot to visualize the relationship between different features. It may take some time because it's plotting all the different plots. You can see the plot is drawn. It shows all the different plots between different feature values. Okay, next plot, categorical plot using sns.getPlot. Here we have all numerical features, but our target variable is a categorical. You can see we do have outliers in 5 and 6 quality rating. So let's do the bivariate analysis using sns.scatterplot. Next, run this. You can see scatter plot is drawn between alcohol and pH, and the different intensity of colors of purple shows a different quality. So yeah, this was it performing EDA. So that's it for today's EDA tutorial. EDA helps you clean your data, select the right features, and avoid costly mistakes in later stages. I hope this guide helps you with your own data science projects. Don't forget to like, share, and subscribe. for more tutorials on Python and machine learning. See you in the next time.